Hello, welcome to our channel for probability and statistics. In this video, we will talk about confidence interval for the mean response in multiple linear regression. So if we have estimated a multiple linear regression model, so one of the purpose of using this model is to predict the mean response value from given independent variables value. Let's say this is the multiple linear regression model written in matrix form, because here x, so here y is n times 1 column matrix, same for this error term, and x is the matrix for n observations and k independent variables plus a constant value, a scalar column, and beta is a vector for the parameter. So the result is n response y. So say if we want to estimate the mean response of y, we call y0 from the given variable of x1, x2, 0, xk0. So we can return mu y given x10, x20 until xk0. So what does mean for the mean variable response? So because we have estimated the confidence coefficient value, then we can just put in x variable. Here we can get a point estimate for the y. And we can omit this because this is the random term, or epsilon means value is 0. So the mean value of y, point mean value of y, is just calculate with this term, fill in x variable and times the coefficient estimated. But for the linear regression, this is a random variable. So if we say test 100 different mean variable, it should be different because this term, right? So this mean value of y is a random variable. So random variable, which means it has a confidence interval. And some mathematical results of this topic is for the mean variable y, so we call the y hat, there is a variance. So this variance equals epsilon's variance, the random term's variance, or sigma square times this term. This term comes from independent variables information. So x0 quote is this row matrix, and x0 is a column vector, and this term is the multiplication of the row and column matrix of x. So this is constant. So all information from this term come from independent variable. So if we know this term, then we can know the variance of y hat. So we can configure confidence interval. But the difficulty is when we never know this one, because this is the theoretical epsilon. We never know this. So that's why we have to use the s square. S is the square root of s square, which is the estimation of sigma square. So if we use s here, we can get a confidence interval for mean response of y given x variable. So this is the y hat 0. This just fill in, get a point estimated from the equation, minus this term, and this is the y hat plus this term. This is the lower bound and this is the upper bound. And if we look at this term, t half alpha is the critical value of the t-distribution with n minus k minus 1 degrees of freedom. K is the parameter number, how many independent variables in the module. And how to calculate S? If we look at this ANOVA table in multiple linear regression, we look at SSE, which is the sum of square error term. So E, error, is the difference between observed y value and estimated y value for individual x variable, right? So this is from the observation. So in all the observation, we can get error between the y observations and the fitted value of this observation. So they are not the same and get an error term. Then we take square of each error term and put it together. So this is called SSE. And SSE divided by n minus k minus 1 called mean SE. This is S square. This is S square. Then we take a square root, can get this S. So everything is ready, and we can calculate the confidence interval for the mean value of y given x value. So next we look at an example. So this example is for the percent survival rate of sperm in a certain type of animal, and after storage was measured at combinations of concentration of 3 variables. So this table listed the y value and x1, x2, and x3. And the question is, construct a 95 confidence interval for the mean response when we know these 3 independent variables. So it is quite clear. We just calculate this y hat point value by filling each term in linear regression equation. So we can get about 24.2. So next we can calculate this term, x vector and its transpose, and this matrix take inverse. So we can get this value is about 0.12. Then we used all the information, can also calculate S square and S value. And from the t-distribution table, we can find the t critical value for the 0.025 is about 2.2 for the 9 degrees of freedom. So because we want to calculate the 95% confidence interval, so which means alpha is 0.05 equals 1 minus 95%, right? So half alpha is 0.025. So that's why we calculate critical value here. So we fill everything in the confidence interval, can get about 25.89 for the confidence interval of the mean response value at these 3 independent variables.